Okay, for this section of 5.2, we're going to pick up on the complement of an event. So the complement is everything else that's not the event. So, for example, if there's a 60% chance of rain today, then there is a 40% chance that it will not rain. Now, the event and the complement should add up to be 1 or 100%. Okay. So the complement is everything else so that the event will not occur. Now, notationally, we use an A with an exponent of C for this, okay? Now, a couple of things here that we look at is that in order to find stuff, you can do that the probability of the complement is 1 minus the probability of the event. You can also flip-flop this and say that the probability of an event is 1 minus its complement. Sometimes it's easier for us to take away what we don't want instead of adding up all the stuff that we do want, okay? So we're going to take a look at a couple of options here, or a couple of examples here as we're processing through. Okay, so this switched. Okay, so we've got if the probability of B is 0.6, find the probability of B complement or the complement, okay? The probability of B complement is 1 minus the probability of B, which is 1 minus 0.6, which is 0.4, okay? And it's that simple, okay? So now, let's take a look at the next one. It says, let E be the event that a car needs engine work while under warranty, and that is 0.08. It says, let T be the event that it needs transmission work under warranty, and then we have the probability of E and T, so it needs engine and transmission work, and this is 0.05. So it asks, find the probability the car needs either engine, transmission, or both. So that's just an or statement. So this is going back to kind of our previous stuff. So pulling that definition, or is the probability of the first thing plus probability of the second minus the probability of both. So we've got 0.08 plus 0.07 minus 0.05. That is 0.10. Okay. Now, with this same setup, they ask for what's the probability that it needs no transmission work. Okay. Well, that's going to be the complement of transmission. So that's 1 minus our 0.07, which is 0.93. Okay. So we can kind of see how that's done. Okay, so we'll look at another example here. Okay. So we've got, there are 27 students. Okay. I'm going to set up our chart here. This is sore throat. This is no sore throat. This is a runny nose. This is no runny nose. 8, and 9, and 11, and 3. Okay. So it says, what's the probability that they have a runny nose? Okay. So we're going to look at, now we've got to take all of our runny noses. Okay. So we've got 8 and 11. Okay. Now, sometimes up here, this is called a contingency table, and it's just a way to organize data. Sometimes they'll run also a total column. So we'll have 19 here and 8 here. We also would have a total column down here, or a total down here. So it's going to be 13 and 14. And then this corner right here tells us the master total, which we'd already said there was 27 students, and we see that matches right down here. So if I want to do running nose, I can either add these up, or since I've already done my setup up here, I've got 19 out of 27. If you put that in decimal rounded at 4 decimal places, we get 0.7037. Okay. Then they ask us to find the probability of having a sore throat. Okay. So we're looking at our sore throats. We're going to come all the way down. We've got 13 out of 27. Again, we can leave that in its fraction notation. We can do math, enter. This one actually won't reduce. Rounded at 4 decimal places, we've got 0.4815. And then they ask us to do, and I'm going to move this up just a bit. Okay. They want us to do the probability of a runny nose or a sore throat. So we know our pattern is going to be the probability of runny nose plus the probability of a sore throat minus the probability that they have a runny nose and a sore throat. Okay. So my runny noses is 19 plus my sore throats is 13. And this is a great example to show why we have to do the subtract. If I stopped right here, that is 32 children. The problem is I only have 27. So we're going to subtract those runny nose, sore throated kids. That's 8. Okay. That is going to give me a grand total of 24 out of 27. That one could be reduced, but I'm going to go ahead and put us into 4 decimal places. Rounded, that is 0.889. Okay. We got 0.8889 on that one. That one will reduce to 8 ninths. Okay. And then we've got one more that we're going to do with this same table, kind of before we move on. Okay. They ask us, what's the probability? No runny, no sore throat. Well, if I just said the probability they have one or the other, okay, this is now the complement of that. So it's going to be 1 minus that 0.889 that we just had, which is going to be 0.111. No runny nose, no sore throat. I can also find it right here in this corner. Okay. But this is the complement of that other one that we just found. Okay. So we're going to take a look at one more example for all of this loveliness. Okay. This is another contingency table one that we're going to look at. And I'm going to move my board way up here so that I can kind of keep all this going. So we've got Bronx, Brooklyn, Manhattan, Queens, and Staten Island. We have open reports, closed reports, and I'm going to add some spacing here, and pending reports. And then we've got some totals over here. And we've also got some totals down here. So this will be a little nicer because they're going ahead and giving us those totals. So okay, and this particular table is talking about reports of graffiti. Okay, and we have open cases, we have closed cases, and then we have pending cases. Okay, and so So this is our lovely table. They do go ahead and give us our totals out on the sides and the bottom edges, so we can do this. So the first one that they ask us to do is find the probability that it's open in Manhattan. Okay, so we're going to look at open cases in Manhattan. So we're going to combine those two up. That is 744 out of our master total of 14,518. Again, I'm going to be running everything out to 4 decimal places. Okay. Next one, they ask for the probability of closed, or is our keyword there, queens. Okay, so we're going to take all of our closed set, which is our 9869. We're going to take all of our queens reports. We're going to subtract our closed queen reports, which is our 2043. Adding all that up and then subtracting, we are going to get that is 11,247 out of our 14,518. Okay, and we get that as 0.7747 for that one. Okay. Clear those, and we'll do a couple more here, a couple more with this table. Okay, so the next one they ask for, find the probability that it comes from Staten Island. So the probability that it's from Staten Island. Okay, there it's going to be 201 of our 14,518. So that is 0.0138. Now again, guys, they didn't ask this, but this would be considered unusual because that is under that 0.05 thing. Okay, now they ask us to find the probability that it's not from Staten Island. Okay, now this is one where it's actually going to be easier for us to do 1 minus the Staten Island stuff that we just got to get the stuff from Staten Island so that I don't have to do my grand total. Okay. Now, if you're running this with numbers, we could also do 14,518 minus the 201. We take the total and we subtract our Staten Island ones. That would give us 14,317 out of 14,518, which again is going to still give us this 0.9862 that we have for that one. Okay. Next one that we're going to look at with this is they want what is the probability that it's closed. Okay. Now again, with this having us already given the total, we're not actually having to total up all of these values. We can just go ahead and pull the total. So we have 9,869 over 14,518. And so that gives us 0.6798. And then the last one they want us to do is the probability of Staten Island or Brooklyn. Okay. So Staten Island's, which is 201. We're going to add all of our Brooklyn minus the overlap. Guys, there is no overlap between Brooklyn and Staten Island, okay? So that's going to be 0, which is going to give me a total of 4125 out of our 14,518, and that is 0.2841 when it's in its decimal format.